Hi, hello, welcome to Dr. Zahid Math. I hope all are doing fine. In this video, I'm going to do some exciting worked out examples from section 2.5 where we will explore two powerful methods for solving differential equations. Number one, substitution method. Number two, Bernoulli's method. First, I'll start with substitution method, a technique that helps us to simplify complex differential equations by making a proper substitution y is equal to vx to transform them into variable separable method. Keep in your mind, after I apply y equals vx, the substitution method goes to variable separable method. Keep in your mind again, variable separable method. In the substitution method, after you putting the substitution y is equal to vx, then final step goes to variable separable method. After that, I will tackle Bernoulli's equation, which is a special type of non-linear differential equation, right? For this method, we are using suitable substitution from the equation itself. And then finally, it is converted into what? First order linear differential equations. Substitution method goes to variable separable method. Bernoulli's differential equation, after substitution, it is going to first order linear differential equations. So which will be very easier to solve, right? I'll walk you through both methods with clear examples so you get a clear idea about both methods. I already have done a couple of problems in substitution and Bernoulli's method in video number in the playlist of differential equation. I think video number 13, 14 and 15. So I will pin this PDF in the first comment and in the description box. Don't forget to download it. If you really understand the problem, please like the video, comment and subscribe it. Okay, subscribe to the channel. Let's get started and make these methods as much as clear. So let's start the first one, substitution method. Okay, right. So what is the equation? X square plus y square into dx plus x square minus xy into dy equal to 0. I need to bring it to the model dy by dx. Why? Usually we bring it to dy by dx to verify whether this equation is a homogeneous differential equation or not. But keep in your mind, you are going to assume the differential equation is homogeneous. So by assuming this homogeneous differential equation, we are directly starting the solving process. We are not checking whether the differential equation is homogeneous by putting x equals tx and y is equal to ty, remember? So we are not doing this one. Directly we are going for solving, right? So now x square minus xy into dy is equal to minus x square plus y square into dx. So I am bringing to this side. So this implies, so dy by dx. So dy by dx is equal to minus x square plus y square divided by x square minus xy. Right. Now we are back to the form. So what we are going to do, we are going to put y equal to vx. After that, we are going to differentiate. Dy by dx is equal to what? V plus x dv by dx. Okay, right. So now in this equation, we are going to put all the values here, right? So v plus x dv by dx is equal to minus bracket open. X is x only, y only we are converting into vx. So x square plus v square x square divided by x square minus x into vx. All the time x must be cancelled, keep in your mind, because it's homogeneous differential equation. So v plus x dv by dx is equal to minus x square, I'm taking common. So 1 plus v square divided by, here I'm taking x square as common, 1 minus v. Why? Because this x into x is what? X square, right? So after this, what happens? Now we are going to write x square gets cancelled. So v plus x dv by dx is equal to minus 1 plus v square divided by 1 minus v. Now I'm going to take this v other side. Okay. So x dv by dx is equal to minus 1 plus v square divided by 1 minus v. And then this minus v I'm taking this side. So this is equal to x dv by dx, which is equal to minus 1 plus v square. After that, I'm taking 1 minus v as an LCM. So minus v, this should be multiplied. v into 1 minus v, because this is v by 1. So this equals x dv by dx is equal to minus 1. I'm taking this minus, and then minus v square. I'm taking this v, so minus v. Then I'm taking this one, it's going to become plus v square divided by 1 minus v. Right, what happens now? V square gets cancelled. Plus v square minus v square. So finally we get an equation x dv by dx is equal to minus 1 minus v divided by 1 minus v. Right, so x dv by dx is equal to, let me take the common term, minus is out, amal mushtarak. So 1 plus v divided by 1 minus v. Right. Okay, now we have come to the stage all the terms get simplified. So in this stage we are going to use variable separable method. What is variable separable method? I told you already in exercise 2.1, right? V should be v should be separated with dv, x should be separated with dx. While you are separating dv with v, dx with x, dv and dx should be in the numerator. Keep in your mind. Otherwise, we cannot go for integration. Okay, right. So here is the v term and this v goes that side. So what I'm going to do, dv, this go as that side. The whole term is going as what? Flip, right? So this 1 minus v goes up, right? Divided by 1 plus v coming down, right? Which is equal to, don't take the minus, dx is going up, okay, and the x should come down. It's clear? Variable separable, we did many things, right? Okay. Now in this stage we are going to integrate. So integral. This is very easy. The integral of this is what? ln x. But this is little bit complicated for your level. So let me do this integration separately and then I'll come back to this and then I'll put it. So listen to this integration carefully. Integral 1 minus v divided by 1 plus v times dv. This is equal to, I'm going to do a small adjustment. Look carefully, right? Suppose I have 5 minus x divided by 5 plus x. What I'm going to do, 5 divided by 5 plus x and minus x divided by 5 plus x. This is what I'm going to do. What I'm going to do, 5 divided by 5 plus x minus x divided by 5 plus x. This I'm going to do it. Okay, right. So the same manner what I'm going to do, 1 divided by 1 plus v and minus v divided by 1 plus v. So it gives the model integral 1 divided by 1 plus v minus v divided by 1 plus v, close the bracket, into dv. At this stage this is very easy because integral of dx divided by 1 plus x is what? We know ln 1 plus x, right? So this will be easily solved. But here it's very difficult. Again v is in the numerator, so it's complicated. Still we need to do some more adjustments. So 1 divided by 1 plus v I'm not touching, but here let me open the brackets, okay, and this bracket close for the whole things into dv. I'll do a small adjustment. What is the adjustment? V divided by 1 plus v, right? I'm adding plus 1, I'm subtracting minus 1. What I'm doing? I'm adding plus 1, I'm subtracting minus 1, so that the value is not changed, not altered, right? So this equals integral 1 divided by 1 plus v, right, minus, there is a bracket, okay. Now the same steps what I did here I'm going to apply. So 1 plus v divided by this one, right, and minus 1 divided by 1 plus v, this step I'm going to do it. So what happens now? Open a bracket, 1 plus v divided by 1 plus v minus 1 divided by 1 plus v, close the brackets. So now bracket close into dv, right? So this equals integral 1 divided by 1 plus v, bracket open, minus, this gets cancelled. So I will get what? 1 minus 1 divided by 1 plus v into dv, right? So this equals integral 1 divided by 1 plus v. I'll take this minus inside, minus 1, and I'll take this minus inside, plus 1 divided by 1 plus v, close the bracket, into dv, right? Okay, now look at this term. The terms are repeating, right? 1 divided by 2 times, right? So plus 1 plus 1. This is equal to 2 times 1 divided by 1 plus v minus 1 times, close the bracket, into dv. Now it's nice place to integrate, right? So now look here. What is the differential of v? 1, which is on the top. So let me split this integral. 2 will come out. 1 divided by 1 plus v into dv minus integral 1 dv. Right. So this equals 2 times, what is the integral of 1 plus v? ln 1 plus v minus, what is the integral of 1? v. So this is what the extra step which I did. So this is the answer for this particular one. So let me go back to the integration. So this part I separately work it out, right? I worked out separately, right? Now I'll put the answer here, which is equal to this, right? So what is the answer? Let me go back to the step, right? The answer is 2 times ln 1 plus v minus v is equal to minus times dx divided by x. The integral is there. So 2 times ln 1 plus v minus v, which is equal to integral of this is what? Minus ln x plus integrating constant what? C. Of course, in many places we are supposed to put, but we are not putting. In the last moment, we are adding c. Right? This is related to ln. This is related to ln. Let me collect these two things together. I'll bring this one this side. So 2 times ln 1 plus v plus ln x is equal to, let me take this v that side. So v plus c. Okay? Right. Now again using logarithmic rule, this goes to the up. ln 1 plus v to the power of 2 plus ln x is equal to v plus c. Right. Now what we are going to do, we are going to use the product rule. You know the product rule. ln 2 plus ln 3 is equal to ln 2 multiplied by 3. So the same idea I'm going to use it. ln 1 plus v the whole square multiplied by x, which is equal to v plus c. Now in this stage, almost all the integrations and the simplifications over. Now we have to back to what? X and y. So we substituted y is equal to what? Vx. So what is the value of v? V is equal to y divided by x. So we are going to put this value here. So ln bracket open 1 plus v, I am going to put it as y by x. V, I am going to put it as y by x. So this equals y by x the whole square, right? Multiply x, close the bracket, which is equal to y by x plus c. Right. One small simplification let me do. Okay, right. So what is a simplification? ln, look here carefully. Let me open this bracket. This is actually 1 plus y. I'm taking LCM as x. So you will get x plus y and then the whole square and then times x, which is equal to, let me use this bracket. Okay, y by x plus c. Now actually what happens, ln, why teacher are you doing this type of step? There is x here and there is x here. I wanted to cancel this. Okay, that's a purpose. So I'm doing x plus y the whole square divided by x square. Yes, if you have a by b whole square, you can write a square divided by what? B square. You can do it. The same idea I'm using, which is equal to y by x plus c. So what happens to this, right? Which is equal to ln, which gets cancelled. Your 1x gets cancelled with this x. So what is your answer? X plus y the whole square divided by 1x is there, which is equal to y by x plus c is the solution for this differential equation. In your book, it is mentioned as c as ln c, but usually if all the equations are in terms of ln, that means all the solutions in the final answer, then we are supposed to put ln. Otherwise, you can write directly c in. Even if you put ln c also, nothing wrong, but let us follow the common idea. Okay, right. So this is going to be your final answer. Right, let's go to the next one. I said one question in substitution method, one question in Bernoulli's method. There are totally 3 examples, but worked example 3 is not up to your level. So we are going to do only worked examples 1 and 2, right? Because worked example 3 need lot of ideas to solve it, but that topics were not included in the class. Okay, right. So let's go to example 2, right? Example 2, we are going to work out, it is Bernoulli's equation. Okay, right. X times dy by dx plus y is equal to x square y square. Solve the Bernoulli's differential equation. Okay. So the question is what? Solve the Bernoulli's differential equation. Right. So Bernoulli's differential equation, we are not giving substitution like substitution method. Y equals Vx. No. We do some steps. After some steps, we are taking the substitution from the equation itself. Problem to problem, the substitution part differs in Bernoulli's method. Okay, right. So what is the general form of the Bernoulli's equations? Everybody knows. In the class I told you what is the general form of the Bernoulli's equation, which is of the model dy by dx plus py is equal to f of x to the power of what? Y power n. If this part is there, then we are going to call it as what? Bernoulli's differential equation. Okay, right. So this is a Bernoulli's differential equation. Okay. So now what are the things you need to do? So the main thing you just keep in your mind, right hand side you should not have y square. Keep in your mind, first thing. And also when you are leaving this y square, try to remove this x also. Try to remove x coefficient should not be there near dy by dx. What did I say? In the right hand side, first is don't keep x with dy by dx. This is the first step. Second step, don't keep y square or y terms. You can say y terms. Here it's y square. Don't keep y terms in the right hand side of the equation. Okay, these are the 2 points you need to keep in your mind. Okay, let's start the equation, right? So the equation is x dy by dx, right, plus y is equal to x square y square. So the first step is what? Don't keep x with dy by dx. So divide by x, divide by x, divide by x. When I divide, what happens? X gets cancelled. X gets cancelled with this x, right? So what happened to this one? So we are getting dy by dx, right, plus 1 by x times y, right? This is equal to xy square. What is the second step? I said don't keep y terms in the right hand side. So now what you're going to do? You're going to divide by y square, divide y square and divide y square, right? So if you divide by y square, 1y gets cancelled with this 1y. Okay, wait a minute. It looks like y power 4. Y square. 1y gets cancelled with this y and this y square completely gets cancelled. So what is your answer? Which is dy by dx here, and there is 1 by y square. Teacher, you said nothing should be near to dy by dx. I said near dy by dx, x should not be there. Don't keep x, I said. I didn't say about y. But here 1 by y square is coming. Plus 1 by x and then 1 by y is equal to x. Clear? Right. What are the steps I said? Don't keep x near dy by dx. Don't keep y in the right hand side. Once this two process is finished, then you can go for substitution. You can go for what? Substitution. What is the substitution? The substitution, you have to take it from the second term. Second term without x. Second term without x. Keep in your mind. So what is your second term here? This is your second. This is the first term. This is the second term. This is the third term. So this is the second term. And this is your substitution you are going to take without x. So that substitution, I'm going to put z is equal to 1 over y. Then the next step is differentiation with respect to x. Y is a function of x. Keep in your mind. We know that differential of x square is what? Which is 2x. When I ask you differential of y square, which is nothing but what? 2y dy by dx. Because we are doing with respect to x. So this is the difference between differentiating x square and differentiating y square. So if I differentiate 1 by x, I will get what? Minus 1 by x square. So if I differentiate 1 by y, right, what answer I will get? I will get the same thing, minus 1 by y square, but at the same time into what? Dy by dx. Keep in your mind. So dz by dx is equal to minus 1 by y square dy by dx. Okay, again I'll repeat. Differential of x square is 2x, but differential of y square is 2y dy by dx. Why y dy by dx? Because we are doing with respect to x. There is no x here, right? This is the one carrying the x with respect to x. Right. The next is what? Differential of 1 by x. What is differential of 1 by x? Minus 1 by x square. Finish. Because we have done with respect to x. But what is the differential of 1 by y? minus 1 by y square dy by dx. Once you finish this part, look at your equation. That's very, very important. Look at your equations. Okay, yeah, right. So look at your equations, and this equations, what you have here, it will come automatically. If you are not getting this term in the derivative part, it means your substitution is wrong. So make sure this particular term should come here after the derivative, because we are bringing to the model dy by dx plus py is equal to q, which is a first order linear differential equations. Okay, right. But we have here 1 by y square, but here we have minus 1 by. So let me take this minus this side. Minus dz divided by dx is equal to 1 by y square dy by dx. Okay, so this is your minus dz by dx, and z is your 1 by y. Clear? Right. So z is your 1 by y. Now all these things I'm going to put it in the differential equation, the top. So this part is going to become minus dz divided by dx. Let me change the color so that it's easy for you. Minus dz divided by dx, which is this part. Finish now. Now plus 1 by x, plus 1 by x, 1 by plus 1 by x. After that 1 by y is what? Z. So which is equal to z, which is equal to x, which is equal to what? X. Clear? Right. So the first term should not be in negative. So what I'm going to do, I'm going to multiply by minus. If I multiply by minus, I will get dz by dx minus 1 by x times z equals minus x. Okay, right. So equals minus x. So what happens now? This is of the model dz by dx plus pz is equal to q. What is this model? First order linear differential equations. While I'm starting the video, I said Bernoulli equation is converted into what? First order linear differential equation. Whereas the substitution method y equals vx converting into what? Variable separable method. Keep in your mind. Right. So what's your P and what's your Q? Just match with this. Just match with this. Okay, right. Your P is minus 1 by x and your Q is minus x. If this is a first order differential equation, what will be your solution? Y, sorry, not y, because this equation z. Z e power integral p dx is equal to integral q e power integral p dx into dx plus c. Okay, so the same idea. This is step number 1 and this is step number 2, and the whole thing we are going to solve it as what? Step number 3, right? So I want to find step number 1, right? So step number 1 is e power integral p dx, which is equal to e power minus 1 by x integral into dx. Okay, right. So which is equal to e to the power of minus integral dx divided by x is equal to what? ln x. So which is ln x. After that, using ln rule, it will be e power ln x to the power of minus 1. Okay. Now we have the formula e power ln a is equal to a. So what is your a? Your a is this one. So automatically this will be equal to what? X power minus 1. Right. So x power minus 1 is equal to what? 1 over x. So e power integral p dx is equal to 1 over x. This is step number 1. Let's go to step number 2. Step number 2 is integral q e to the power of integral p dx dx into dx, which is equal to integral q is minus x. We just already called. And this is from step number 1, right? Which is 1 over x into dx. This equals x and x gets cancelled. So what I will get? Minus integral dx. So what is the integral of minus dx? Integral of minus dx is equal to minus x. So this equals minus x plus integrating constant c is there, but we are not putting. So this is your step number 2. So we got step 1 and we got step 2. Now we are going to put it all these things in z e power integral p dx, okay, is equal to, right, integral q e power integral p dx into dx plus c. So now z bracket open e power integral p dx, what we got? I think I got 1 over x. Yes, 1 over x and minus x. 1 over x, which is equal to, this part I got it as what? Minus x plus c, right? So almost we are nearing to the step. So which is z over x, z divided by x is equal to minus x plus c, right? Now we are back to what? Our substitution. What did I give? Z is equal to the substitution, because z is a dummy variable I gave, right? So you should go back to y and x, right? So what is the substitution I gave? Z is equal to 1 over y. So this one I need to maintain in the final answer, right? So z is equal to 1 over y. This is the substitution we made. Is this the same substitution for all the Bernoulli's equation, teacher? No, no, no. Problem to problem substitution differs. But whereas in the substitution method, for all the problem, you are going to take y equals vx. Okay, right. So what happens now? We are going to put z equals what? Y by, z equals what? 1 by y. So 1 by y, 1 by x equals minus x plus c. I want something y equals. So what I'm going to do? I'm going to multiply by x. When I multiply by x, I will get here 1 by y. Here I will get what? Minus x square. Here I will get what? Cx. But I want to give the answer y equals. So y equals flip. Okay, yeah, right. So 1 divided by, only flip the term. Don't flip the negative positive. So minus x square plus cx is going to be your solution for this Bernoulli's differential equation. Okay. So only 2 worked out examples are there in this exercise, right? Okay. So this PDF, I will put it in the first comment as well as in the description. So please download it and just while you are studying, just work it out side by side. If you really understand this video, like it, comment it and subscribe it. Thank you for watching. Have a good day. All of you take care. Bye bye.